Hello all, welcome to Docker Basics to Brilliance course. My name is Kastro Kiran. In the last videos, we have understood how to create the Docker volumes by using the different methods that are available. I hope you are now aware of how to create the Docker volumes and how to work with the Docker volumes concept. As a part of this particular video, we are going to start a new concept that is available in Docker, which is known as Docker Compose. This particular concept we are going to discuss in 3 to 4 parts, where I will also be covering 2 real-time projects which are based on Docker Compose. Particularly, as a part of this particular video, I am going to give a brief overview about what is meant by Docker Compose, how we are going to use Docker Compose in the real-time scenarios, and how Docker Compose is going to help us in order to simplify the management of the containers and also the architectures or the application architectures, which consists of microservice based architecture. So let's understand the concept of the Docker Compose. So let's understand the concept of Docker Compose. But before directly jumping into the concept of Docker Compose, let me give you an overview of what we have discussed so far in the concept of the architecture or the application architecture. Usually in real-time scenarios, for any application, for any application, we have 3 major components. We have 3 major components. What are those 3 major components? The first one is known as front end of the application. And the second one is known as the back end of the application. And the third one is known as database of the application. Front end component, back end component, and database component. Front end component is nothing but the user interface of the application. Back end component is the place where we store the application source code. This is also called as the business logic layer. And database component is the place where the application related files or the user information of the application will be stored in the database. These are the 3 major components that will be available for any type of application that are being developed in the real-time scenarios. Now, if you remember, we have also discussed about the application architecture. In general, we have 2 types of application architecture. The first one is known as monolithic based architecture. The first one is known as monolithic based architecture, and the second one is known as microservice based architecture. This concept also we have seen in the very beginning of our Docker classes. I would recommend you to watch this particular videos where I have discussed in detail about these concepts. But as a part of this video, I am just giving you an overview of these concepts. So the applications are being developed by using one of these 2 methods, either monolithic architecture and microservice based architecture. Now coming to the monolithic based architecture, this is something which is not preferred in the real-time scenarios. This is not something that is preferred in the real-time scenarios. In real time, we always deploy the applications by using the applications which are created by using the microservice based architecture. Now, what is meant by a monolithic architecture and what is meant by a microservice based architecture? Monolithic architecture is something where the entire project, the entire project, let me write that, the entire project will be available as a single unit. The entire project will be available as a single unit. Suppose, let's say I have a Java based project or I have a Python based project. Now what we are going to do, I will create one Docker container, and inside that Docker container, I am going to deploy the application. That means what I am doing, the entire application, I am going to deploy in a single container. All the application related information and also the application, I am going to deploy in a single container. When you deploy the entire application in a single container, that's called as monolithic architecture. Mono means single. Everything that is related to the project, I am going to keep it in a single container. But if you keep everything related to the application in a single container, Is it a recommended approach of deploying the applications? It is not a recommended approach. Why? By any chance, if the container gets failed, the entire application will see the downtime. So that is why monolithic architectures are not preferred in the real-time scenarios. But in real-time scenarios, which one we are going to use? We are going to prefer microservice-based architecture. Now, what does it mean by a microservice-based architecture? Suppose, let's say, I have an application called Netflix application. The same example I have taken in the very beginning sessions of this Docker lecture series. I would recommend to watch those videos as well. So in the Netflix, if you remember, we have different components. Suppose, let's say in Netflix, we have movies category, we have animations category, we have web series categories. Like this, we have different categories in the Netflix application. Now, what I am going to do, instead of keeping all of these categories in a single container, what I will do is I will create a separate container for movies, I will create a separate container for animations, and I will create a separate Docker container for web series. And along with that, I will also create a separate database for movies, separate database for animations, and separate database for web series. Like this, what I am going to do is the application, okay, whatever the whole application is there, I am not going to keep the entire application in a single container. Instead of that, what I will do, we call these as APIs, that is application programming interface. Movies related API, I will keep in a separate Docker container. Animations related API, I will keep in a separate Docker container. And web series related API, I am going to keep it in a separate container. But here the thing is, creating individual containers for each image is a complex task. Suppose, let's say I want to create a separate container for this one. Now, if you want to create a separate container for movies, then you need to create a separate image. For animations, you need to create a separate image. For web series, you need to create a separate image. So here, that's basically a complex task. So we need to simplify that. So we need a solution where I can manage multiple containers. Okay, we need a solution where I can manage multiple containers by using a single command. Okay, by using a single command. Typically, it is difficult to create more and more containers by using Docker run command. Docker run is a manual command, but we can execute that. But let's say your application is having some 100 containers. Now, 100 times you have to execute the Docker run command. 100 times you have to execute the Docker run command. Why we need to run those many commands? Because we have different microservices. Movies is one microservice. Animations is one microservice. So for every microservice that is available, you need to create one container. Before creating the container, you need to create an image. And this is all a manual process, which is a complex process. If we have only 2 or 3 microservices, that's fine. But if you have n number of microservices, then that task becomes complex. So to overcome this problem, okay, to overcome this problem, we have the concept of Docker Compose. Okay, we have the concept of Docker Compose. So to overcome the problem of creating multiple containers by using multiple images by executing one command is a complex process. So to overcome this kind of problem, that is executing the same command multiple times or creating the multiple containers by using the same command, it's a complex process. So what I am going to do, I am going to use a concept which is provided by Docker that is known as Docker Compose. Now here, as I was mentioning, creating multiple containers. Let me write that. Creating, creating multiple containers manually is a complex and time-taking process. Okay, time-taking process. So we need to simplify that. So to simplify, okay, to simplify the creation of multiple containers for an application, we will use Docker Compose concept. Okay, we will use Compose concept. So I hope you are now aware that why Docker Compose has came into picture. Now let's understand how Docker Compose is going to simplify the task of creating multiple containers. That we need to answer, or that we need to understand. So as of now, what we understood, managing multi-container based application is a complex process. So for that, what we are going to use, we are going to use Docker Compose. Okay, we are going to use a Docker Compose. So Docker Compose is used for, let me write that, Docker Compose is a tool which is used, okay, which is used to manage multi-container based applications. So if your application is having multiple containers, like movies one container, animations one container, web series one container, so this is a multi-container based application. Netflix is basically a multi-container based application. So Docker Compose is a tool which is used to manage the multi-container based application. How it is going to manage? So using Docker Compose, okay, using Docker Compose, we can easily set up, okay, we can easily set up and deploy the multiple containers. We can easily set up and deploy the multiple containers. We are going to understand this one practically when I am talking about two projects in the Docker Compose concept. So here we will use the Docker Compose to simplify this process. Okay, we will use Docker Compose to simplify the process of managing and creating multiple containers. But what we have to remember here is in real world, we only have the microservice based applications, not the monolithic based application. That's something that we are going to remember. And since we are using microservice based application, and that is where Docker Compose is going to come in the rescue to help us create and manage multiple containers. Okay, to create and manage multiple containers. So here in Docker Compose, we are going to use a file. Okay, in Docker Compose, we are going to use a file. Okay, we will create a file which is known as Docker Compose file. Okay, Docker Compose file. Just like Docker file, in Docker Compose, we are going to create a Docker Compose file. What we are going to create in the Docker Compose file, we are going to tell to the Docker Compose that what are the APIs that need to be created, how they need to be created, what should be the port numbers that need to get enabled. All those things, we are going to keep it in the Docker Compose file. How to write a Docker Compose file? What are the components that are involved in the Docker Compose file? We will understand that in some time. But let us look into the way of the Docker Compose file. Okay, the Docker Compose file is having an extension, is having an extension as .yml or .yaml. So you will create the Docker Compose file with an extension as .yml or .yaml. They both are same, but the full form of YAML is yet another markup language. So you can give YAML or .yml. Anything you can give, the Docker Compose file will get executed. Now let's understand the components of the Docker Compose file. Components of Docker Compose file. So what are the different components that will be there inside the Docker Compose file? Just like how we have different components or different keywords in the Docker file, here also we are going to have the four major components in the Docker Compose file. The first one is known as a version. Okay, the first one is known as a version, and the second one is known as services. The second one is known as services, and the third one is known as network. Third one is known as network. And the fourth and last component is known as volumes. Version, services, network, volumes. These are the four major components of the Docker Compose file. In order to explain these ones, I am going to take a practical real-time project where I'll be showing you how to write a Docker Compose file by using all of these four different components. So currently, just have an idea about what are the different components that will be there in the Docker Compose file. These are the four major components that will be there in the Docker Compose file. So the Docker Compose file will have a name as Docker Compose.yml. Okay, Docker Compose.yml. This is how you can create the Docker Compose. So can we create a different file or can we change the name of the file? Yes, you can also change the name of the Docker Compose file. If you want, you can keep your own name and you can execute. But as far as real-time scenarios is concerned, in real-time scenarios, we keep the name of the Docker compose file as docker-compose.yml or YAML. Now, where we are going to store this Docker compose file? The Docker compose file we will store in the project repository. Okay, in this we will store in the project repository. That's basically the GitHub repository. So in every GitHub repository of the project, we will be having the Docker compose file. Okay, we will be having the Docker compose file. So Docker compose file should contain all the information related to the containers creation. Whatever containers that you want to create, all that information we are going to provide in the Docker compose file. So let's understand what are the different Docker compose commands that are available. Docker compose commands. Once after we understand the Docker compose commands, then we will practically see how to work with the Docker compose concept by using a project. So first, let me list out what are the different Docker compose commands that are available. Suppose, let's say, if you want to create containers, okay, if you want to create containers using Docker compose. So the command which is used to create the Docker containers using Docker compose is Docker compose. Okay, Docker compose up up. Docker compose up is used to create containers using Docker compose. That's the first command. Suppose if you want to create, okay, if you want to create containers using different file name, okay, using different file name. What is the default file name? Docker compose.yml. Suppose, let's say, I'm not going to use the Docker compose file. I said earlier, can you change this file? Yes, you can change this file name. If you have a different file name, now in that case, if you want to create containers using a different file name, then the command is docker compose. The command is docker hyphen compose space hyphen f. Hyphen f represents a file, and then give the file name. Whatever file that you have given, that name you have to give, and then space up. So if you have the Docker compose default file, then you can directly execute Docker compose, yeah, up. But if you have a different file name, Docker compose hyphen f, and then give that file name. Okay, and then give that file name and then up. So that the Docker container will get created with the custom file name, whatever you have provided. Okay, suppose if you want to run Docker containers, okay, if you want to run the Docker containers in detached mode, okay, if you want to run the Docker containers in detached mode by using Docker compose command, the command is Docker compose up hyphen D. Here hyphen D represents in the detached mode. Okay, hyphen D represents in the detached mode. Now the other command is if you want to display, okay, if you want to display the containers created by Docker compose. If you want to display the commands created by Docker compose, the command is docker compose ps. Okay, docker compose ps. Suppose if you want to display, okay, if you want to display or see the list of Docker images, okay, list of Docker images, which are created by Docker compose, okay, which are created by Docker compose. So if you want to see the list of Docker images created by Docker compose, the command is docker hyphen compose images. Okay, docker hyphen compose images. Suppose if you want to check the container logs, okay, to check the container logs, the log information of the containers, whatever you have created using Docker compose, the command is docker logs hyphen f, and then give the container name. Whichever container logs you want to see, that name you have to give. Okay, and if you want to remove all the Docker containers, okay, to remove all the Docker containers which are created by Docker compose, okay, to remove the Docker containers which are created by Docker compose, the command is docker compose. Okay, docker compose. If you want to create, the command is up. Okay, the command is up. If you want to delete, the command is down. Okay, the command is down. So to create the containers, docker compose up. To delete or to remove the containers, the command is docker compose down. So this is how we are going to work with the different Docker commands. So what is the default Docker file name? Default Docker Compose file name, not Docker file, Docker Compose file name. What is the default Docker Compose file name? Docker Compose, docker-compose.yml, or you can also give YAML. Anything will work. Okay, YML or YAML. So these are the different commands that are available in the Docker commands. In the next video, we are going to work with all of these commands, and I will also show you how to create a Docker Compose file. So as far as this video is concerned, we have just discussed the concept of Docker Compose. So we have understood what is meant by Docker Compose, how Docker Compose is going to help us to manage the multi-container based application, and what are the different components that are available in the Docker Compose file, and the commands which are related to the Docker Compose. So by using these things, in the next 2 to 3 videos, we are going to work with the Docker Compose concept in a practical way. This is all about this particular video. In the next video, we will see how to work with the Docker Compose as a part of the real-time scenarios. Thank you.